Welcome to the channel. We are going to be performing a post hoc test on one of the questions we've solved so far. Alright, one of you actually requested for this video. So I am making a post hoc test on the first question that we solved on CRB. Now first, what is a post hoc test? A post hoc test is a follow-up test. A follow-up test. That is, after ascertaining that there is significant difference within the means of the treatments that you have, analyzed. Now you carry out a test to specify or identify which particular treatment is significantly different. After your whole analysis, you are going to accept or alternative hypothesis if F cap is greater than F tab. So once you have accepted the alternative hypothesis, which is a hypothesis of similar difference, then you carry out a post hoc test. Now there are so many post hoc tests in statistics, but in the context of this course, we are going to be using LSD, only these two, LSD and DMRT. And you see, DMRT is the one that is most, it has the highest protection level. So meaning that it's likely to give you the most correct and precise answer. So while the LSD is, this one is usually used for a lot of when the means are much, they are large, and LSD is used for when the means are not that much. For example, here the means are not that much. But I've decided to, because of LSD is quite easy to do, so I've decided to start with the DMRT. I'm going to be using DMRT as a post hoc test for this question. If you don't know where this question comes from, I've linked the video in the description below, where we first analyzed this question using ANOVA, one-way ANOVA, and we got F count to be greater than F tab, which means that one of the means, or two or three, or the three means are significantly different from each other. Alright, so I'm going to be using the DMRT. The LSD basically is called the Fisher LSD. That's LSD, Fisher's LSD. That is least significance difference. Least significance difference. Least significant difference, rather. And it should not be confused with Latin square design. That is a type of design. And DMRT means Duncan's multiple range test. So that's what we'll be using here. Now, the Duncan's multiple range test has a lot of steps, so you have to follow attentively and just follow intently. Alright, so we are using DMRT. The first thing to do here is to calculate the means. Alright, let's generate the means for these values. We have 1, 2, 3, 4, 5. 5 divided 115.6 divided by 5. That gives 23.12. 187.6 divided by 5 still. We have 37.52. Then 123.6 divided by 5. That gives 24.72. So what we basically want to analyze is which of these means are significantly different from each other. Okay, so the first thing to do using DMRT is to rank your means. Now there are two types of ranking you do. You rank for the means themselves, then you will now rank also for their there's something called the DP values. So you also rank for that. But let's do the first ranking, where we'll have from what we rank in ascending order. So which one is the smallest? Ascending means from smallest to the biggest. So the smallest is 23.12. 23.12, so we have 23.12, followed by 24.72, followed by 37.52. So we've ranked in ascending order. So what we basically want to do is compare the means. Compare the means. And how do we compare the means? We are going to be using our we are going to be calculating what is called the standard error. The standard error. The standard error is given by the formula MS error. It's actually this formula, MS error over N. So, but after calculating this, you are going to still multiply with the RP. You are going to multiply with the RP. Alright, so, and so standard error is actually this, the mean square error over the replicate. That is formula for standard error. So then if you now multiply with this, so standard error becomes the DP, which is called is a Duncan's value, is the Duncan's critical value, and it's called the least significance range. The least LSR, least significant range. That's the DP value, and it's gotten by the SX times the R sub P. Right. So you know how to calculate S sub X already. So S sub X is equal to MSE. From our calculation in the previous listing, we got that MSE is equal to 0.83. So I'm going to substitute that here so that we have square root of 0.83 all over N. What is our N or R? You can also use R to represent 1, 2, 3, 4, 5. So we have over 5. So that we have 0.83 divided by 5. 0.883 divided by 5 is equal to square root of 0.166. Alright, then square root of 0.166 is going to give us 0. So our SX value is equal to 0.41, actually 407. So I approximate to 2 decimal places. So we've gotten our SX value. Now, the next thing to do is to generate our DP value. Now, in order to generate our DP value, we are going to rank again. So now we are going to have, now the ranking is going to start from two levels, from the 2 levels, then graduate to 3 levels, 4 levels, and above. Now, the first rank is not rank 1 because we'll be comparing 2 means. So the mean has to start from 2. The ranking has to start from 2. So we have rank 2. Rank here. The next one is going to be rank 3. So now, if we rank in the first case, we are going to be having we're going to have their DP values. Let's calculate their DP values first. Their DP values is going to be, for this guy in rank 2, for the guy in rank 2, we'll have, so we said that we're going to be calculating the DP values. Alright, and the DP value is given by the SX, which is the standard error, times RP. Now, I said, how do we get the RP value? You go to it's called the RP, the R standing for ranking as well. So you go to, now I told you that we start the ranking from rank 2 because even in your Duncan's table, so you go to the Duncan's table to actually get your R value. So even on the Duncan's table, you start from it starts from under 2, not under 1. So we rank from rank 2, rank 3, like that. So for the first rank, the RP, okay, let's use the RP first, is going to be 3 points. I'm going to check for the error that we are checking for is, we are checking for 12 under 2. Then we'll check for, we'll now increase the treatment, DF treatment. We'll go to 12 under 3. So we'll check for 12 under 2. That is as per the question, from our ANOVA table. Remember that we had our DF error. Our DF error was 12, and our DF treatment was 2. So we'll go to check DF error under 2, so rank it under 2 here, and DF error under 3, and rank it under 3 here. So now it follows that the number of means that you have, because you are ranking from the highest to the biggest, the number of means that you have will determine how many ranks you have. So for this place, we have 3 means, we are going to have 2 ranks. So those are rank 2 and rank 3. If we have 5 means, we are going to have 4 ranks. Rank 2 to rank 4, and to rank 5, of course. So that is still 4. Those are still 4 ranks. So our RP value for this case was 0.3.081. That is using checking it under the alpha equals 0.05. Alright. So then for the rank 3, we checked for 12 under 3, we had 3.225. Alright. Take note of this probability value. 95%. You must always check. Alright. Then we now get our DP value. Okay, let's put our SS value under each. Our SS value was 0.41 and 0.41. So we're going to multiply both of them to get our DP values. So our DP value here is 3.081 times 0.41. And that gives us 1.26, right? So this is our first DP value, and the second DP value is going to be 3.225 times 0.41, and that is 1.32. Alright, so this is our second DP value. So lastly, what do? We now begin to compare. Please understand the fact that this ranking is related to how many means that you have. If you have 8 means, your ranking will contain 7 ranks, so that you have from 2 to 8. If you have 3 ranks, your ranking will contain 2 ranks, which will always start from 2 to that last number. Alright, so then so that's basically it. Your RP is gotten from the Duncan's table. Use your DF error and DF treatment. You get this and this. Alright, so by yourself. Now this one we check with respect to the rank. We check under the first one, then we'll keep increasing it. So if we start from 4, it's going to increase to 5. Alright? So then the next one here, we get this one from the calculation. Alright? So what we now do next is the actual comparison. So we have our comparisons here. And then we have our mean deviations. Or the mean differences between them. The mean differences. Then how many steps apart they are from each other. Steps apart that they are from each other. Then the last one is going to be okay, that's second to the last. We'll now compare with our DP value. We are using our DP value to actually compare with the difference. So then if we have similar difference, we will conclude. At the end of the day, we'll now conclude. So the last part of this table is conclusion. Let me make sure that is showing well. Conclusion. Conclusion. So we have this DP value, this DP values. Alright. First we are comparing, we've arranged them in the ascending order. So we can name them A, B, and C. Alright. So let's compare, the highest is C. So first we'll compare C and we'll subtract C from, we'll subtract the slowest one from C first, and the lowest one is A. So C from A, then C from B, then B from A. Alright. Then their mean difference is now will be 37.52 minus A being 23.12. Then the next one 37.52 still minus 24.72 equals and 24.72 minus 23.12. Okay, so now there are steps apart. We are going to write our answers there, but let's do the steps apart. How many steps apart is 37.5 away from this one? There are 3 steps apart. 1, 2, 3. So there are 3 steps apart. How many steps are these and these apart from each other? 2 steps apart. B and A, how many steps? 1, 2. So there are 2 steps apart. Then the DP, we've calculated the DPs. So let's write them here. The first one is, so the ones that are the one on rank 3 is going to be, so this is the major reason for the ranking. The one on rank 3 is going to get that 1.32. The one on rank 2 is going to get 1.26 and 1.26. Let me take that again. After your steps apart, you go to your DP values. Your DP values correspond with the one that you calculated, the SSX times this. You know you actually multiply this. Or multiply it. So your DP values, after your steps apart is important here, so that you can be able to compute, know which one owns the DP value. So the one that is 3 steps apart, that is the one that owns the DP value of 1.3, which is on rank 3. The one that has rank 2 is the one that will own DP value on rank 2. Alright. So then the next one, so let's now compute this. We have 37.52 minus 23.12. That gives us 14.4. Alright, I'll write the remaining answers. So these are the DP values that we will have. I mean, these are the different mean differences that we will have. Here we have 14.4, 12.8, and 1.6. Then the next thing we'll do is we'll compare the mean differences with our DP values. So anyone that is greater than our DP value will be significantly different, and anyone that is less than our DP value will be will not be significantly different. We have no significant difference. Alright. So here, if we compare this guy and this guy, this mean difference is bigger than this guy. So what does that mean? It means it's what is significantly different. So we use asterisk to to represent that. This one is also greater than this, so this is significantly different. This one is also slightly greater than this, it's also significantly different. So all our means are significantly different. Hence, when we want to segregate them using letters, separate them using letters, we have C, B, and A. It's best what you do is you will arrange in descending order here. So when you arrange in descending order, you have it that, is this guy a significant difference? Yes, it is. So you can allot it. I'm going to write your mean, C, B, and A. The mean for CB, you got the mean for C rather, you have 37.52. The mean for B, 24.72. and the mean for A 23.12. So this one was significantly different, right? So we allot letter A. This one was significantly different, we allot letter B. This one was significantly different, we allot letter C. And it mean this one was not significantly different, or one was not significantly different, it will have the same letter as another. So when they have unique letters, then it means they are significantly different. Alright, so that is it on the DMRT. We are going to use the LSD to solve the other problem on post hoc test. We are going to carry out a post hoc test also on the second question. I'm going to link it. It's going to be the second link. It is the second link in the description. Alright, so if you have not seen that, if you have not seen that video, so that you will know where all these data set came from. Okay. But this time we are going to be using LSD. Now, LSD is quite similar than the DMRT, or maybe I would say it's not as lengthy in operation as the DMRT, and it's actually called the Fisher's LSD. So now we have gotten our means. So I've computed the means out. All of this, I added all of this and I divided by 5, which are the number of replicates. I got this and this and this and this for each of those treatments. Now, my LSD is given by the formula T alpha over 2, df error square root of times now, of course, the square root of 2 ms error over r. Alright, in this case, it's almost the same like the DMRT. We are taking the standard error first, then we are multiplying by a particular t value, which is like from the t-test table. Alright, since our alpha here is 0.05, and we simply slot in our value. Okay, but before that, our df error, if you remember from that question, our df error was 16. And then our ms error was, let me look at what our ms error is. The error was calculated to be 4.32. That was the error, alright? So, the replicate, of course, we have 1, 2, 3, 4, 5. 5 replicates, 5. So I guess we have all that we need to solve now. So we go to, then on the t-test table, okay, let's start the solving. We have LSD equals t sub alpha, which is 0.05 over 2, comma, our df error is 16, close bracket, multiplied by 2 by MSE, that's 4.32 over 5. So that we have is equal to t, 0.05 over 2 is going to give us 0.025, comma 16 by this. And this is going to give us 4.32 is going to give us 8.64 over 5. And 8.64 divided by 5, 8.64 divided by 5 is 1.73. So we have 1.73 here. We are taking the square root of that. Then we will now check for the value of t, the t value under 0.025, using an error, a df error of 16. And how do we check that? On our t-test table or t distribution, we are going to see alpha. We're going to see alpha here. So alpha is under 0.025 here, 0.025. You see that? So we are going to go down to 16. This is 16. Then we'll trace it here. And we'll have, that is around 2.12. So we have 2.12 times this. So the square root of 1.73 is equal to 1.32. So 2.13 times 1.32. So the answer is 2.80. Okay? So 2.80 is the LSD value that we have here. Alright, so this LSD value, the use of this LSD, Fisher LSD, the advantage is that you don't need to compute for several values. What you just do is use this one value to compare with every other values. Now, how do you do that? You now do what is called the pairwise comparison. Pairwise comparison. And this method is similar to that of the DMRT, where you list all your means. So I could use, so I have my means here. Let me arrange my means from the highest to the lowest here. I want to arrange all my means. So if I arrange all my means here from the, let's use from highest to lowest, yes. We have 21.47. We have, so let's call that A. Then 19.42, let's call that B. Then we have 18.49, let's call that C. And 16.47, let's call that D. So the first thing we're going to do is we're going to compare this guy with every other guy here. So that we have A minus B, A minus C, A. You can do it any way you want, but so you can start with A minus the last and the rest. So, but I want to go in this order. A minus D. Then A has, pair being compared with all of these three. We move to the next one, which is B. B minus C, B minus D. Then we go to the last one, C minus D. So to know how much of this you will have, just do combination analysis. 4 combination 2. We are combining two things pairwise. So 4 combination 2 is going to give you 6. How do you do that? 4 factorial over 4 minus 2 factorial, that's 2 factorial. So you have 4 by 3 by 2 factorial. So that you have over 2 factorial. So that you have 2 factorial, 2 factorial. The formula of combination is n factorial over n minus r factorial, r factorial. So we include the 2 factorial again. So 2 factorial is 2 times 1. 2 takes care of 2 here, so 2 times 3 is 6. Just use combination in your calculator. You get how many values how many comparisons you should have here. 1, 2, 3, 4, 5, 6. Alright? So let's compare. A minus B, that's 21 minus 4, 7, and minus 19.42, and 21.47, 21.47. Here it will be minus 18.49. Here it will be minus 16.47. You saw what I did? So the next one will take B, 19.42 minus 18.49, 19.42 minus 16.47, and then 18.49 minus 16.47. Alright, so let's begin to get our critical values. So these are the values that we use to compare with our LSD value. Alright, by the time we subtract the following, I'm going to write the answers down. These are all the critical values. So what do? We begin to compare. So we compare 2.80 with each one. Now, if 2.80 is greater than it, then it is not significant. But if our critical value is greater than 2.80, then it is significant. Here, 2.080 is greater than it, so it is not significant. Here 2.98 is greater than that, so it is significant. Here it is significant, it is greater than that. Here it is not significant, it is less than that. This one is greater than that, it is significant. This one is less than that, it is not significant. Alright, so having obtained these values, then the next thing we'll do is we will now use letters to denote their significance, the significance we have. So we are going to also order the means. We are going to arrange the means according to that same order of descending order. So we have A, which was 21.47, B, C, D. B, which was 19.42, C, which was 18.49, and D is 16.47. So what we essentially want to do is to see if the ones that are signaling difference, I told you they are going to have different values, different we're going to use different letters to represent them, while the ones that have the same values, we use the same letters to represent them. So when we compare this guy and this guy, it is not significant. So A is here, A will be here as well. Now when we now compare this guy and this guy, is it significantly different? When we compare this guy and 18.5, yes, it is significantly different. So let's use B to represent that. When we now compare, we are done with that. Let's now compare this guy and this guy. Are they significantly different? B and that is this guy and this guy. B and C. No significant difference. So what do we use? We can use a separate letter now, but in that separate letter is going to be that separate letter will appear. So let's compare them again. When we compare this and this, there is no significant difference. So between means that don't have significant difference, we put the same letter. Alright? Now let's compare B and C. Let's compare this guy and this guy. There is no significant difference as well, so we can put B here. And since this guy is not significantly different from this, we can put B. We'll put back B here again. Let's compare the next one, C and D. No significant difference. Then we can put another letter, C and C here, to represent that there is no significant difference between this guy and this guy. But if I check between this guy and this guy, it means there is significant difference because there is no letter here that is here. Alright? Between this guy and this guy, there is no difference. Why? Because there is no letter that is here that is here. So that is the essence of this lecture. Alright, so with this we come to the end of the post hoc test. Do well to subscribe to the channel and click the bell notification. Thank you and God bless you.